Today I share Infinite Shadow's question on the important question, is this thermal paste important to CPUs? My name is Steve Smith, this is TQA Weekly. Of course, you can email me at ask@tqaweekly.com, go to my website, tqaweekly.com, and ask me questions, send me comments, even suggestions, or even interactive community. And of course, there's always down below if you're watching on YouTube, blip.tv, Vimeo, or anywhere else I post every single week. For the last few days, I've been talking with a user from YouTube called Infinite Shadow about the importance of this thermal paste. Yes, I've done an episode maybe 2 or 3 months ago about the importance of thermal paste and how to apply. I'm going to reiterate very simply for everybody else because he already, or she, I'm presuming he from the name, so sorry if I'm wrong. But about the importance of thermal paste and what it actually does, because a lot of people just don't know. This is AMD and this is Intel. What is similar about these two things, besides the fact they're relatively the same height, is the fact that they are both the part of the computer, excluding the GPU for some people, that actually creates the most amount of heat in your computer. Neither one of them is efficient enough to actually create a workload without actually creating heat in the process. For this purpose, we have always had a heatsink minimum on every single processor that actually handles all of the data transactions and program executions of a computer. And we have used for a really long time a fan on heatsinks because of how hot these things get. They have safe operating temperatures in which they will function in, and outside of these safe functioning temperatures, they will step down performance to avoid damage. If catastrophic damage is imminent, they would rather shut down computer to your face than actually burn up. So you literally have to disable every security parameter in your computer to get the computer's processor to fail. However, under some circumstances, i.e. overclocking, you could achieve this task so much faster than the computer can operate and detect this that the processor will in fact fail. So, under the circumstance of heat, I have in fact seen processors fail due to heat. But what normally happens is the computer shuts off in your face. What does the thermal paste do though? Well, these things have a texture. Much like the bugs that can walk on your wall, these have a texture. And no amount of people telling you on any forum that if you were to buff and sand these things, will the texture actually come out. You will just end up creating another texture. So, all you're doing is changing the playing field. The playing field still has a problem. So this is also true for the heat sink. Now, when we connect them both together without thermal paste, we have what is known as air pockets. These air pockets create an air gap that can actually insulate against the cold and of course against the heat, not allowing the processor itself to fully transfer all of the heat effectively from itself to the heatsink, preventing it from first going through all the cycles of high heat, throttling, and then shutting down in your face. Because of all this technology that allows it to protect, you're not going to see very much damage very often because of that. Now, the best way to prevent that from ever occurring, and the easiest way to allow heat to be dissipated efficiently, is to use thermal paste on the processor itself, allowing it to actually function correctly, allowing it to have a lower temperature, which, by the way, will actually lengthen its lifetime, allowing it to function for a really, really long time. And this in itself will prevent a lot of the damage that is normally correlated with high heat, no thermal paste actions, which some people to this day still believe is a gimmick to make more money. It's not. A tube like this has enough thermal paste in it for anywhere from 15 to 25 computers in it. So you might as well buy one tube and keep it for a really long time, because It's actually very useful to you to change the thermal paste anywhere from 6 months to 2 years, whether yourself by following one of my other episodes or by going to your local computer store to get it done, where it would actually be probably best if you don't know how to do it. So, why do I think, for those who are interested, why do I think that people don't actually get problems that are not actually using thermal paste with CPUs? Well, I'm presuming that a lot of the people running a computer without thermal paste aren't doing tasks that are heavy enough for it to be warranted. A processor will simply not go up on a motherboard in the amount of power that's required if there's nothing being required of it. In the case of people that are gamers, people that are content creators like myself, people that actually create and edit videos, do sound works, do 3D works, or doing a lot of work simultaneously with multiple spreadsheets and word processing and our emails and all of this software in there, there will be a necessity of having a thermal paste because there will be a demand from the processor to operate, and that would cause the processor to fail over time because those instances would actually force the computer to just turn off. And if it's anything that you would like to try with a computer that you don't mind doing with it, you could actually try it without the thermal paste and try to push it. You will see that it will do something very distinctly. It will step down performance and then it will just turn off. In some rare cases, if the security was turned off for the temperature, it would just blow. As in, you wouldn't notice it blew, it would just turn off and it would never start back up ever again. No, I'm not doing that experiment because it is a waste of the board and it is fairly toxic to throw these things away in the dump. So, subscribe if you haven't already done so, like if you like this episode, and share with those that you believe could actually benefit from this episode. Have a great day.